We're on SAT Practice Test 9, Math, Section 2, Question 1. What's the level of difficulty here? It's remarkably easy. You got some numbers. What's the median of the data shown? Write down what you're looking for. The only way you can mess this up is if you don't put in the very small amount of work required to make sure that you get it right. Time me. Alright, that took about 15 seconds, and it's going to take you about half the time when you're writing on paper. Watch this. Median 79. You can get this question right extraordinarily quick, but you do need to take the time to make sure that you don't make a dumb mistake. Get it right and move on. We're on SAT Practice Test 9, Math Section 2, Question 2. What's the level of difficulty here? It's easy. This is the last easy question. Right triangles LMN and PQR are similar, where L and M correspond to P and Q respectively. Angle M has a measure of 53 degrees. What's the measure of angle Q? So we're looking for angle Q. Write it down and circle it. Where are these figures? They're not here, so you got to draw them. Anybody can draw two right triangles. The triangles are similar. What's that mean? Same shape. Okay, these are basically the same shape. L and M correspond to P and Q. M has a measure of 53. So let's just start by writing M. Put it anywhere but the right angle. Doesn't really matter where L and N go. But you got to make L and M and P and Q correspond. So P goes here. Where does Q go? Here. And I guess R goes here. Okay. M is 53 degrees. They're similar triangles. That means they're the same shape. What do you think Q is? It's 53 degrees. Answer is B. It's a very quick problem. It's exactly the same as problem 21 on section 1 of this test. I don't really think it's any easier, but you can get both of them right and move on. We're on SAT Practice Test 9, Math Section 2, Question 3. What's the level of difficulty here? This is reliably the first medium question on Section 2. From here on out, it's medium and hard and crazy hard. Got a table. Table shows three values of x and their corresponding values of y for the equation y equals 4 times 2 to the x plus 3. In the table, a is a constant. What's the value of a? So write down what you're looking for. A. Remember that a constant just means ETS knows what a is. They're just hiding from you. It's not a variable. This is just a function. Write down the function, and then if you want to, run the first set of numbers. X is 1 and y is 11. So 11 equals 4 times 2 to the 1 plus 3. Sure enough, 4 times 2 is 8 plus 3 is 11. So hey, the function works. Let's try it with 3 for x. How would that work? Y equals 4 times 2 to the what? 3 plus 3. Y equals 4 times, what's 2 to the 3? 8 plus 3. That's 4 times 8, which is 32, plus 3, which is 35. And so the answer is B. You can get this right much quicker than I just took. I just wanted to show you how the function works, and you move on. We're on SAT Practice Test 9, Math Section 2, Question 4. What's the level of difficulty here? It's medium. Got this equation. How many solutions does the given equation have? These problems come up on every SAT. They're very formulaic, and you can get them done in about 2 seconds if you understand what's going on with them. If you don't understand what's going on with them, you can always plug in. If you're going to plug in, write down A, B, C, D. Let's write down the question real quick, and then let's just start plugging in. Let's make up our favorite number in the world, x equals 2. So if x equals 2, what's the equation? We don't even have to do it in our calculator. Just write it down. 66 times 2 equals what? 66 times 2. Is that an equation? It is, because both sides are the same. Can you cross off anything? Well, it can have 0 solutions, right? Because it has at least one solution, so the answer can't be D. All right, let's get weird. How about x equals 0? If x equals 0, 66 times 0 is 0, equals 66 times 0, which is 0. Is that an equation? It is, because both sides are the same, right? So can it have exactly one solution? No, because we just found 2. All right? Now, and we could go on and do another one, but think about it. If you plug in something else, what's going to happen? They're going to be the same. They're always going to be the same because x and x are the same on both sides. So how many solutions does this have? Infinitely many. You can get this right real quick, whether you just know it or plug in, and you move on. We're on SAT Practice Test 9, Math Section 2, Question 5. What's the level of difficulty here? It's medium. It's a long, boring story. A model predicts that the population of Bergen was 15,000 in 2005. The model also predicts that each year for the next 5 years, the population P increased by 4% of the previous year's population. Which equation best represents this model where x is the number of years after 2005 and x is less than or equal to 5? So let's write down what we're looking for. It's a function, and we're really just looking for which function. Guys, this problem is a plug-in. How do I know? Well, it's a function. It's got p and x in the problem. It's got p's and x's all over the answer choices. I can plug in, what do SAT functions love? SAT functions love 0 and 1. So I'm going to write ABCD, and I'm just going to plug in 0 or 1 to start. I'm going to start with 0. If I make x equals 0, what is 0? The number of years after 2005. So 0 years after 2005, what year is it? It's 2005. And in 2005, what's the population? It's 15,000. So the population P, if x is 0, is what? 15,000 equals 0.96 times 15,000 to the 0 power. Anything to the 0 power is what? It's 1. Okay, is all this true? It is not true. So A is gone, and it's not coming back. I'm not going to write 15,000 again. It's 15,000 every single time. 15,000 equals 1.04 times 15,000 to the 0 power, which is 1. All right, does 15,000 equal 1.04? It's not. It doesn't. So B is gone forever. All right, let's try C. 15,000 equals 15,000 times 0.96 to the 0 power. That's 1. Does 15,000 equal 15,000? Yes, it does. Should you pick C and move on? No, you should try D. D says 15,000 times 1.04 to the 0 power. Anything to the 0 power is still 1, so it's 1. 15,000 equals 15,000. So C and D both work when we plug in 0. We should expect that for 2 reasons. One is a lot of times 2 answer choices work when you plug in on functions, and 0 is weird, and 1's weird. So it's natural to expect that more than one answer will work. Let's try 1. So I don't need to do A and B. This time I'm going to ballpark. I don't know what the population is, but if I increase it by 4% after 1 year in 2006, it's going to go up, right? So if it's going to go up, I got an increase of population equals 15,000 times 0.96 to the 1. So 15,000 times 0.96. Is that going to go up or down? Well, the population is going to go down a little bit because 15,000 times something less than 1 means you're going to go down. If you're not sure, put it in your calculator and see. I was looking to go up. That goes down. Let's try D. Again, I don't know what the population is if I ballpark, but I know it's going to have to go up. Equals 15,000 times 1.04 to the x equals 1. Is that going to go up? Yeah, it's going to go up just a little bit. 15,000 times a little more than 1. It's going to go up just a little bit. If you're not sure, put it in your calculator. D is the only one that goes up. It's got to be the answer. And by the way, it goes up 1.04. That's 4%. You can get this right much quicker than we just took to do it here when you plug in and move on. We're on SAT Practice Test 9, Math Section 2, Question 6. Level of difficulty is medium. The function h is defined by h of x equals 4x plus 28. The graph of y equals h of x in the xy plane has an x-intercept at a0 and a y-intercept at 0b. A and b are constants. What's the value of a plus b? So write down what you're looking for. Circle it. And then we're going to take this problem in a really important SAT concept, bite-sized pieces. And that means just do the problem one step at a time. Function h of x equals 4x plus 28. Anytime you see a function in SAT land, it's going to be y equals 4x plus 28. Or y equals whatever's on the right side. Alright, the graph in the xy plane has an x-intercept at a0. So let's just consider that part. What's important about the x-intercept? There's one thing and one thing only. It's that y equals 0. Alright, so if you think about it for a second, you're on the xy plane, right? So you've got an x and a y. It's a0, right? Y is 0. So x is going to be the same thing as a. And at the y-intercept, there's only one thing that's important about it. What is it? It's that x equals 0. So again, if you think about it on the xy plane, 0b, what's y? It's b. So all you got to do is plug in 0 for y and 0 for x. And you're going to have this problem solved really easily. So let's write y equals 4x plus 28. Let's make y 0 equals 4x plus 28. 4x, we're going to move the 28 across, so it's going to change signs. Divide both sides by 4. And you've got x equals negative 7. We said x is the same thing as what? A. So what is a? A equals negative 7. Okay, you're halfway done. The second part's way easier. You're going to make x equals 0 this time. So y equals, well, it's just 4 times 0, which is 0, plus 28. So y is 28. All right, y is 28. What else is y? Y is b. So b is 28. So all you got to do is add negative 7 and 28. Do it on your calculator if you want. It's 21. And so the answer is A. Taken in bite-sized pieces, medium questions do take some work, but you get it right and you move on. We're on SAT Practice Test 9, Math Section 2, Question 7. Level of difficulty is medium. Guys, this is an absolute classic plugin. How do I know it's a plugin? The variables all over the answer choices. There's variables in the problem. There's no constants. Which equation is equivalent to this big old mess where x is bigger than 7? All you got to do is make up an x that follows the rule. Got to be bigger than 7. About x equals 8. So we're just going to plug in here. I'm going to rewrite this whole thing. You don't have to rewrite the whole thing. Just makes it easier for us to do. So 8 times x is 8 times 8, 64. X minus 7 is 8 minus 7, so times 1. Minus 3 times, already did that, 1. Over 2 times x is 2 times 8, 16 minus 14, which is 2. So it's 61 over 2. Circle 61 over 2. That's what we're looking for. So I'm going to rewrite the answer choices. I'm going to space them out. A says x minus 7. I said x is 8. So 8 minus 7 over 5. That's 1 over 5. Is that 61 over 2? It is not. It's gone. B, 8x, 64 minus 3, 61 over 2, golden. Should I check C and D? Sure. So this is going to be 8 times 64. I'm going to do that one on your calculator. That's 512 minus 24 minus 14 over 2x minus 14. You know what that is. It's 2. you can ballpark. You don't need to do anything else. This thing on top is not going to be 61. You know that 8x squared is 512 minus 24 minus 77 over 2, again, ballpark, that's not going to be 61. And so the answer is B. Plugging in is faster and easier than doing algebra, and you will always get it right. You will not run into whatever wrong answer mistakes Evil Testing Service has for you. You can get this right pretty quick and move on. We're on SAT Practice Test 9, Math Section 2, Question 8. What's the level of difficulty here? It's medium. This is the last medium problem that you're going to see on the SAT. Everything from here on out on Section 2 is going to be hard or crazy hard. Circle A has a radius of 3n and circle B has a radius of 129n, where n is a positive constant. The area of circle B is how many times the area of circle A. So I'm going to write down what I'm looking for. Doesn't have to be fancy. Circle B, how many times circle A? And guys, this problem is a plug-in. And most of the time, you cannot plug in when there's a constant, because constant is usually something that ETS knows, but they're hiding from you. But plugging in is an art, it's not a science. And you can know when you can plug in if you do enough plugging in. And this is a time, even though there's a constant, when you can plug in. So how do you plug in on this problem? Well, you're going to make n something. It can be anything in the world. It's got to have to be positive, though. What do you want it to be? What's your favorite n in the whole wide world? Mine's 2, because it's nice and small. It's very predictable. So circle A has a radius of 3n, 3 times 2, which is 6. And circle B has a radius of 129n, so 129 times 2. So the area of circle A, pi r squared, pi times 6 squared, that's easy, that's 36 pi. This one's pi r squared again for circle B. This is pi times 129 times 2 squared. So get out your calculator. That's 258 squared. It's going to be a big number. But what do you care? You got a calculator. So it's 66,564 pi. Okay, so if you want to figure out how many times B is A, you're going to divide. You divide 66,564 pi by 36 pi. Pi's are going to go away. 66,564, it's already on your calculator, divided by 36. It's 1849. That's the answer, and it's D. You can get this right very quickly and efficiently if you plug in and move on. We're on SAT Practice Test 9, Math Section 2, Question 9. What's the level of difficulty here? It's hard. This is the first hard question in Section 2, and everything from here on out is going to be either hard or crazy hard. A circle has center O, and points R and S lie on the circle. In triangle ORS, the measure of angle ROS is 88 degrees. What's the measure of angle RSO in degrees? And then you don't put in the degree symbol when you write down your answer. So what's the big problem here? As always, Evil Testing Service is describing a figure, but you don't see it. So you got to draw it. Draw your figures kind of big, and then you're never going to be able to draw them to scale, but try to do a good job. So it's got the circle has a center O, and then ROS is 88 degrees. Well, that's about 90 degrees, so let's make it look like that. It's about 90 degrees. Here's R, here's S, 88 degrees goes here, ROS. It's a triangle, so you got to make a triangle here. All right, what's the measure of angle RSO? RSO. So you're looking for this angle right here. All right, first of all, let's just pretend that you have no idea what to do. If you have no idea what to do, What do you think you could say about these two angles? The way it's written, the way I've drawn it, do they look about the same? They do look about the same. So you could just take 180 minus 88. You're going to get 92. You divide 92 by 2, and you get 46. And you could just guess that. And guess what? You'd be absolutely right. So I encourage you to ballpark if you don't know what else to do. But let's see why this is the right answer. Something comes up in SAT land a lot is in triangles, big angles are across from big sides, small angles are across from small sides, equal angles are across from equal sides. What do you think equal sides are across from? Equal sides are across from equal angles. Equal angles are across from equal sides are across from equal angles. Do we have equal sides here? Well, what is this? It's a radius, right? It's a line from the center out to the circle. What is this? It's a radius. It's a line from the center out to the circle. So are these sides the same? They're the same. What are equal angles across from? They're across from equal sides. So that means that this angle and this angle, which are across from two equal sides, are equal. There's 92 degrees in these two angles. You divide it by 2, and you get to 46. And that's the answer. You can get this right very quick and move on. We're on SAT Practice Test 9, Math Section 2, Question 10. What's the level of difficulty here? It's hard. A business owner plans to purchase the same model of chair for each of the 81 employees. The total budget to spend on these chairs is $14,000, which includes a 7% sales tax. Which of the following is closest to the maximum possible price per chair before sales tax the business owner could pay based on this budget? Guys, this is a plug in the answer choices problem. How do you know? It's a story problem. It's asking for a specific thing, price per chair before sales tax, and you have a strange and inexplicable urge to set up an algebraic equation. When those things happen, you can plug in the answers. When you plug in the answers, you want to be very clear on what you're looking for. What are we looking for? We're looking for the price per chair before tax. So write down A, B, C, D, kind of spread them out, and then just start with an answer. Where should you start? You should start in the middle, because if you're wrong, you can see a lot of the times if it's too big or too small. So let's start with C. Let's say the price per chair is $172.84. So what do you do with that number? Well, you got to add the 7% sales tax. So you're going to take 172.84 times, don't mess this up, it's 0.07. It's not 0.7. And you're going to get about $12.10. You can add up the full decimal number on your calculator back to 172.84. You're going to get 184.94. You're going to multiply that times 81, the number of chairs. And when you do that, you're going to get a number that's about 14,980. Is this right? No. Why? Because we can only spend $14,000, and here you're spending $14,980 and a few more cents. So that's wrong. What else has to be wrong? Well, anything bigger. So you got it down to A and B. Let's try B. If the price is $161.53, let's do the same process again. 161.53 times 0.07, not 0.7. You get about $11.30, but you can just do this decimal number on your calculator, add it back to 161.53, and you're going to get about $172.84. But again, it's a decimal, and you can just keep it on your calculator what are you going to do with that? You're going to multiply it by 81. And when you do that, you're going to get 13,999.805. Okay, could this be the answer? Yeah, it could be the answer because it's under 14,000. Is it really close to 14,000? It's really close. You think it's the maximum possible price? The maximum number of chairs? It's got to be because it's so close to 14,000. So that's the answer. When you plug in the answer choices, you can be absolutely sure you're right. It's faster than algebra, it's easier than algebra, and you can move on. We're on SAT Practice Test 9, Math Section 2, Question 11. What's the level of difficulty? It's hard. A right triangle has legs with lengths 24 and 21. If the length of the triangle's hypotenuse can be written as 3 root d, d is an integer, what's the value of d? So what are we looking for? We're looking for d. All right, as usual, Evil Testing Service has described a figure, but they don't show it to you, so draw it. It's a right triangle. The things that aren't the hypotenuse are 24 and 21, and the hypotenuse is 3 root d. You've been doing this particular problem since what? 3rd grade? It's the Pythagorean theorem. A squared plus b squared equals c squared. I'm going to go through several steps here. You could probably skip a few of these steps when you're actually doing the test, but I want you to see it, so we're going to go through them. So it's 24 squared plus 21 squared equals c squared. Obviously, calculator math. 24 squared, 576, plus 21 squared, 441, equals c squared. So you add those two numbers up. C squared equals 576 plus 441, which is 1017. All right, how do you get to c? So you take the square root. So c equals square root 1017. What's c? C is the hypotenuse. So the hypotenuse, I'll do it up here, 3 root d equals square root 1017. You could do some algebra here, but you don't really have to. Think about this. A square root is a prison, and it's a prison because square roots suck. If you're a perfect square, you get to escape the prison. The 3 has escaped the prison. So there must be a perfect square in here, and what is the only thing it can be? It has to be 9. 9 times what is 1017? So you divide 1017 by 9, and you get 113. So 9 gets to escape, right? Becomes the 3, and then trapped inside is the 113. 3 root 113, that's the same as 3 root d. So what's d? It's 113. It does take a little work, although again, you could probably skip a couple of these steps, get it right, and move on. We're on SAT Practice Test 9, Math Section 2, Question 12. What's the level of difficulty? It's hard. The positive number a is 230% of the number b, and a is 60% of the number c. If c is p% of b, which of the following is the closest to the value of p? So what are we looking for? P. First thing here is ETS says which of the following is closest to. That's a license to round, so don't get caught up in decimals. Second thing is this problem is a plug-in. How do you know? Well, you got a bunch of letters in the problem. And then secondly, Evil Testing Service is asking you to find a percent, could also be a fraction of something, but they don't tell you what the something is. When that happens, you just plug in. This problem is based on percents. What are percents based on? Percents are based on 100. So you need one of these numbers to be 100. That's going to be the easiest thing. Which one? The easiest one is to make b 100. If b is 100, then a is 230% of b, so a is 230% of 100. go ahead and do it. 230% of 100. So A is just 230. A is 60% of the number C. So A, 230, is 60% of C. When I have fractions and non-fractions, I want to make everything a fraction so I can see when I can reduce and when I can cross multiply. This is just going to be 3 over 5. So I'm going to say 230 over 1 equals, smushing everything together on the right side, 3C over 5. Cross multiply. 3C equals, obviously calculator math, 230 times 5. It's 1150. You can divide by 3. And when you divide 1150 by 3, you're going to get 383.33, goes on forever. But remember we said we have a license to round. So we're just going to round that to 383. All right, so what is C? 383. C, 383, is P% of B, which is 100. So 383 is P% of B, 100. It's easy enough. 383 equals P, and that's your answer. It's D. Couldn't be faster, couldn't be easier, way easier than doing it the algebraic way. You get this right when you plug in, and you move on. We're on SAT Practice Test 9, Math Section 2, Question 13. What's the level of difficulty? It's hard. You got x is bigger than 0. The function f is defined as follows. F of x is equal to 201% of x. Which of the following could describe this function? All right. I'm going to be crossing off in this problem, so anytime I know I'm going to be crossing off or even think I might cross off, I want to write A, B, C, D. Guys, we're on a run of plugins. This is another plugin. How do you know? Well, it's because a function can be any numbers, and all you got to do is follow the directions and plug in some numbers. So let's plug in a number for this function. What's your favorite number to plug in the whole wide world? Well, mine's 2. Why? Because 2 is really easy, really small, really predictable. All right, so x equals 2, 201% of is times x. Strongly encourage you to use fractions and not decimals on the SAT. They're way, way easier. You have a calculator. So it's 201% of, I said x is 2, so it's 2. Do it on your calculator. 201 times 2 divided by 100. You're going to get 4.02. All right, what can we do with that information? Very little. We got to plug in again to see what's going to happen. Is it going to go up, down, and how? So let's just plug in the next number, 3. We plug in 3, it's going to be 201% of 3. Once again, do it on your calculator. 201 times 3 divided by 100. And when you do that, you're going to get 6.03. And now we can get somewhere. First of all, did it go up? Did it go down? Well, it went up, right? So if it goes up, it ain't going down. So what can I cross off? A and B. How did it go up? Well, we can subtract to find out. The change here is 2.01. Now what should you do? Well, you should plug in the next number, 4. Plug in 4, 201% of 4. More calculator math. And when you do that, you're going to get 8.04. Okay, what's the change? Again, subtraction. 8.04 minus 6.03. The change is 2.01 again. All right, so is it increasing exponentially or linearly? You got to know the definitions of these words. Linearly means like changing in an orderly fashion, the same way every time. And exponential means not doing that. So is this changing the same way every time? Yeah, it looks like it is. So what's the answer? It's D. When you plug in, you can get this right quickly. You know you're right, super easy, get it right, and move on. We're on SAT Practice Test 9, Math Section 2, Question 14. What's the level of difficulty here? It's hard. You got this chart. The table gives the coordinates of 2 points on a line in the xy plane. The y-intercept of the line is k minus 5b, and k and b are constants. What's the value of b? So we're looking for b. Let's write it down and circle it. This problem is one of those problems that it's like a puzzle, and you kind of got to put it together. There's a few different ways to put it together to get to the same result. But what are the two major pieces that you're going to need? Well, it's a line in the xy plane. Is there an equation for that you've seen for years? Yes. It's y equals mx plus b. Gonna need that. And then y-intercept comes up a lot. What is y-intercept? Only one thing that matters about it. Y-intercept is when x equals 0. And x-intercept is when y equals 0. So y-intercept, though, x equals 0. All right, y-intercept of the line is k minus 5b. Well, isn't it true that any point is xy? Yes. So this point is k minus 5b. The y-intercept, x equals 0. So what's k minus 5? K minus 5 is 0. All right, so what's k? Pretty easy algebra here. K is 5. All right, let's head over to this little chart. So I want to rewrite it, but I don't have any mystery. There's no more k's anymore because k is just 5, 13. And then for the second one, k is 5, k plus 7 is 12. That's minus 15. So you now have all the components you need. Y equals mx plus b. What else can you find? We can definitely find the slope. That's m. How do you find slope? y2 minus y1 over x2 minus x1. I'm going to start with 13. So it's 13 minus negative 15. Be careful with that. That's 13 plus 15, 28. Okay, so I started with 13, so I got to start with 5. 5 minus 12, what's that? It's negative 7. 28 over negative 7, what's that? It's negative 4. So my line is y equals, the slope is negative 4, x plus b. I'm golden. What do I do now? I got all these, I got 2 points, so I can plug one in. Should I use the easier one or the harder one? Let's use the easier one. Y, 13, equals negative 4 times x, negative 4 times 5, negative 20, plus b. All right, that's easy enough. I'm going to move the negative 20 over across the equal sign. It's going to change signs. And I'm going to get b equals 13 plus 20, which is 33. And guys, that's what b is, and that's the answer. This problem is a hard problem. It's not crazy hard, but it does take some work. It does take some steps. Write them down, get it right, move on. We're on SAT Practice Test 9, Math Section 2, Question 15. What's the level of difficulty here? It's hard. Keenan made 32 cups of vegetable broth. Keenan then filled X small jars and Y large jars with all the vegetable broth he made. The equation 3x plus 5y equals 32 represents this situation. Which is the best interpretation of 5y in this context? So what are we looking for here? Well, we're looking for what's 5y. This problem is algebra and words. These problems come up on every SAT. Email Testing Service usually makes them easy, but as you can see here, can also make them hard. They can make them medium too. Anytime you see these kinds of problems, you want to deconstruct what's going on. So let's just start, and you should always start, by writing down what the letters are. What is X? It's small jars. And what's Y? It's big jars. What else do we have? We have an equation, 3x plus 5y equals 32. On algebra and words problems, you're going to want to cross off, so write A, B, C, D. What are we looking for in this equation? We're looking at 5y, trying to decide what it is. What is y? We said y is big jars. So you can always go and cross off answer choices that are going to say what y is not. Small jars. A says number of large jars. All right, that's cool. B says number of small jars. No, y is big jars, so that's gone. C says large jars. All right, that's cool. D says small jars. All right, that's gone. You can always get these down to 2 answer choices if you can just figure out what the letter's about and cross off answer choices that don't agree. Now, 5y, there's 2 things in it, right? There's a 5 and there's a y. What's the y? Y is the big jars. And what's the 5? 5 is, well, it's the number of big jars. Okay, what's A say? A says number of big jars. Is that 5y? No, man, that's just 5. So that's gone. C, the only answer that's left, says total number of cups of vegetable broth. So that's 5, the number of y, the large jars. It's the thing combined. It also happens to be a much more complex answer than A. And if you think about it, that's much more likely to be right on a hard question. You can get these right very quickly, very methodically, no matter what the level of difficulty, and move on. We're on SAT Practice Test 9, Math Section 2, Question 16. What's the level of difficulty here? It's hard. We're getting towards the end, so it's getting to be crazy hard problems. This problem is not crazy hard, it just requires a lot of work. So you've got an equation. One of the 2 equations in a system of linear equations is given. The system has no solution. Which equation could be the second equation in this system? All right, this problem is simultaneous equations. How do I know that? Because I have 2 equations. I've got this equation, and then I've got a system of equations. So one of these other equations is going to be in the system. There's going to be 2 of them. Simultaneous equations, they're always the same. You're going to stack them and then add them or subtract them. Hard problems have a lot going on. There's more going on here. This system, these simultaneous equations, has no solution. What is no solution? No solution is when all the variables drop out when you stack the simultaneous equations and add or subtract. So we're just going to have to start by writing stuff down. Let's write down the equation here, and let's just start with A. We're going to have to do some crossing off, so we're going to write A, B, C, D. All right, A says x equals 4y. Now, there's no number here, so what's the number? It's 0. I can't add or subtract these and make anything go away, so what I got to do is multiply or divide one of the equations. I'm going to multiply this equation by 3. And when I do that, I'm going to get 3x equals 12y plus 3 times 0, 0. All right, this doesn't matter anymore. I'm going to draw a line, and now I'm going to add or subtract. I can subtract 3x minus 3x is 0 equals 36y minus 12y. That's 24y. Did all the variables drop out? They did not. They don't. So this is not the answer. Now I got to do B. Told you there's a lot of writing. This time I'm going to write less. So for B, it's 1/3 x equals 4y, and again, there's no number, so it's plus 0. All right, again, I'm going to have to multiply one of these equations, or I could divide. I'm going to multiply this one. I'm going to multiply it by 9. Why 9? Because I want to get 9 times 4 is 36. So if I do that, 9 times 1/3, be careful, that's 3x equals 9 again times 4 is 36y. All right, now, we're going to run out of space here. If I subtract, what's going to happen? Are the variables going to go away? They totally are. So this is definitely a potential answer. Let's keep it. I'm going to get rid of all of this, and I'm going to do C now. X equals 12y minus 15. All right, same deal. I can't add or subtract, so I'm going to multiply this one. I'm just going to multiply it by 3. So it's 3x equals 3 times 12, 36y, and then 3 times negative 15 is negative 45. Okay, so now think about this. When you add or subtract them, what's going to happen? Are all the variables going to go away? Yeah, I mean, I guess if you think about it that way, they are, but take a second look, man. This is the same equation. So if it's the same equation, it doesn't have no solution. That cannot be the answer. That is a very tricky answer. All right, and now I'm going to do D. Down here, where we're completely run out of room. 1/3 x equals 12y minus 15. And again, this time I'm going to multiply by 3 so I can get the 12y to 36. So that's going to be 3 times 1/3, which is just going to be x equals 3 times 12y is 36y minus 45. All right, if I now subtract, 3x minus x is 2x. I get the y's to go away, but I didn't get the x's to go away. All the variables did not drop out. That one's gone. B and C are tricky. B is the answer because all the variables drop out and it's not the same equation. A lot of work, but you can get it right and move on. We're on SAT Practice Test 9, Math Section 2, Question 17. What's the level of difficulty here? It's definitely hard. Most people are going to find it stupid hard. The first 16 questions on Section 2 of SAT Practice Test 9 are not that bad. Section 1's not that bad. And then from this point on, most of the questions are just ridiculous. They're really hard. You got this equation. Which of the following are solutions to the given equation where a is a constant and a is bigger than 30? So the way you want to approach problems like this with these Roman numerals is just write the Roman numerals and then write A, B, C, D so you can cross off. And the second thing, I just want to talk about the way the problem is written. Which of the following are solutions? And then every one of these answer choices has like more than one solution. So what can you say about this equation? How many solutions does it have? Definitely has more than one. Let's write the equation. And then looking at these 3 Roman numerals, what's going to be the easiest thing to do here? Well, the easiest thing to do here is definitely Roman numeral 3 because it's saying which of the following are solutions. Solutions are what the x is, a is a constant, and 3 is suggesting that, hey, maybe a solution is 29. So let's just see if x can be 29. Every time you see an x, put in a 29. That side 0 equals 29 minus a times 29 minus 29, which is 0. So that's side 0. So is this a solution? It is because both sides are the same. Both sides are 0. So does Roman numeral 3 work? It definitely does. So you can go and you can cross off any answer choice that doesn't have Roman numeral 3 in it, which unfortunately is only A. B, C, and D all have 3 in them. All right. So another way to think about this, I'm going to rewrite this. You don't really have to do that if you're in the event of a real SAT. But remember how I was talking about how there's more than one solution here? So we've taken care of the 0 solution. Now, how can we simplify this equation? Well, don't both sides have x minus 29? They do, right? So I'm just going to divide this whole thing by x minus 29. And when I do that, what's going to happen on the left? I'm just going to get 1. X minus 29 over x minus 29. And what's going to happen over the right, on the right? I'm going to get x minus a. So I can simplify this thing to 1 equals x minus a. It's a lot easier to deal with. And now, what can I do? You are not supposed to plug in almost all the time for constants, but sometimes you can. And in this problem, you can if you just think about, well, what am I trying to figure out with the constant? What do we know about the constant? It's bigger than 30. So all this means is there's a number here, ETS knows what it is, they're hiding it from you, and it's bigger than 30. So let's just see what would happen if we make A something bigger than 30. How about 31? If we did that, we'd have 1 equals x minus what? 31. And then what would x be? X would be easy, it'd be 32. Well, what can we figure out here? Between Roman numeral 1 and Roman numeral 2, what's going on? Well, at least in this one case that we found, x is a plus 1, isn't it? What's going to happen if you make a 100? It's going to be 1 equals x minus 100, so x is going to be 101. It's always going to be a plus 1, right? X is always going to be a plus 1 if you plug in an a bigger than 30. So is 2 always going to work? 2 is always going to work. So let's go and cross off answer choices that don't have 2 in them, that we haven't already crossed off. All right, how about, well, B doesn't have 2 in it, but C and D both have 2 in them. Okay, well, now we got to think about Roman numeral 1. And really, you're pretty much done here, because the solution, if you make a constant bigger than 30, if you make it 31 or 100, it's always going to be a plus 1. X is never going to be the same as a. You can't make it the same as a, so you just say, man, it's got to be C. We're on SAT Practice Test 9, Math Section 2, Question 18. What's the level of difficulty here? It's hard. The last part of Section 2 Math on SAT Practice Test 9 is a lot of crazy hard questions, but this one's real easy if you'll plug in. How do you know it's a plug in? Well, you got letters in the problem, and there's letters all over these answer choices. 1 gallon of stain will cover 170 square feet of a surface. A yard has a total fence area of W square feet. Which equation represents the total amount of stain, S, in gallons, needed to stain the fence in this yard twice? So write down what you're looking for. It's stain fence twice. If you don't RTFQ, you're going to get this question wrong. Read the frickin' question. All right, 1 gallon is what? 170 square feet. We want to do W square feet. We can make W whatever we want. What do you want it to be? How about 170? That's really easy. So W is 170 square feet. All right. We want to do it twice. So how many square feet is that? It's 170 times 2. And do it on your calculator. 340. But in any case, how many gallons are you going to need to do this thing twice? 1 gallon is 170. 2 gallons is 340. So write down 2 and circle it. We're going to want to write down A, B, C, D because we're going to want to cross off. A is W over 170. That's 170 over 170. That's 1. Obviously, it's not 2. This is an answer choice that's going to mess people up if they don't see the word twice, if they plug in, or if they do algebra. B is 170 times 170, and that's obviously not 2. C is 340 times 170, and that ain't 2. Man, I hope this works. W, 170 over 85. Time to get out our calculators. What do you know? It's 2. And so the answer is D. You can get this right so fast if you plug in. Be sure you're right and move on. We're on SAT Practice Test 9, Math Section 2, Question 19. What's the level of difficulty here? It's hard. Most people will find this stupid hard. A lot of people are going to find it crazy stupid hard. I'm going to show you how to do this problem, of course, but let's pretend that you have no idea what to do. Is there a strategy? And there is. On hard questions only, you can pick the weird one. It works a remarkable amount of the time. Just go to the answer choices, ignore the question, and cross off answer choices that are relatively normal looking based on the answer choices. So what's relatively normal looking here? Obviously negative 100. What else? I think the next one is negative 9 over 2. A and C are really hairy looking, so if you're just going to guess between A and C. But let's do the problem. In the xy plane, the graph of the equation y equals negative x squared plus 9x minus 100 intersects the line y equals c at exactly one point. What's the value of c? So we're looking for c. Write it down and circle it. There's two equations here. You can skip this step, but think about it. If y is this thing and y is this thing, what are these two things? They're the same. So you should start by saying c equals negative x squared plus 9x minus 100. And then the other thing that you want to know, you're dealing with a quadratic equation. This is what a quadratic equation basically looks like. If you have exactly one solution, intersects at exactly one point, then b squared minus 4ac has to be 0. This is worth remembering, because we're putting in your calculator. b squared minus 4ac is the key here. It could either be 0, or bigger than 0, or less than 0. When you have exactly one solution, b squared minus 4ac is 0. Keep that in mind. So when we have quadratic equations, we have to set everything equal to 0. So I'm going to make the left side 0, which means I'm going to move the c across, so it's going to change signs. So I've got negative x squared plus 9x minus 100 minus c. All right, this is really ugly looking. Why? Because I got a negative x squared. I don't want that. So I'm going to divide through by a negative, and I'm going to get 0 equals negative x squared, which is x squared, minus plus 9x minus 9x, minus 100, it's plus 100, minus c plus c. Okay, got a quadratic equation. In the quadratic equation, even if you don't think you've been doing quadratic equations, you have since 9th grade. Looks like this. Do we have this thing? We do, ax squared. So what is a? A is 1, 1x squared. What is b? B is negative 9. C is a little tricky. C is everything else. So C is 100 plus C. And then all you got to do is plug this stuff in to this equation over here. So what's b squared? It's negative 9 squared, 81, minus 4 times a, 4 times 1, which is 4, times c. So times 100 plus c equals 0. Got to distribute here. 81 minus 400 minus 4c, right, equals 0. All right, I'm just going to move my 4c across the equal sign, make it positive. 81 minus 400, calculator math. It's negative 319. Oh, we're home free, man. Divide by 4 to get c by itself. And so c is negative 319 over 4, and that's answer choice C. This problem is hard. It takes some work, but you can get it right, and you can move on. We're on SAT Practice Test 9, Math Section 2, Question 20. What's the level of difficulty here? The level of difficulty is this problem sucks. Don't rush through Section 2, because you're going to get to these really hard problems, and SAT Practice Test 9 particularly has hard problems at the very end. It's not very hard up until the very end, and then it just gets killer. The quadratic function g models the depth in meters below the surface of the water of a seal t minutes after the seal entered the water during a dive. The function estimates that the seal reached its maximum depth of 302.4 meters 6 minutes after it entered the water, and then reached the surface of the water 12 minutes after it entered the water. Based on the function, what was the estimated depth to the nearest meter of the seal 10 minutes after it entered the water? What the hell is going on in this problem? Well, let's just start by drawing a picture. Here's a little baby seal. That's a baby seal. What's happening right here? It's like on a rock. Gets in the water, goes down, it's like a function, so it goes all orderly and such, comes back up, lives through the process. What is this? It's a parabola. All right, what is the information we have? We have a bunch of information here. We've got a bunch of x's and we've got a bunch of y's. First of all, what is x and what is y? Y is pretty easy. It's going down or going back up. It is the depth of our seal. What's x? X is the time that it's taking for this process to go. So at the very beginning, we've got 0 time and 0 depth, right? That's right here, 0, 0. What's another point that we have? This, in the middle of the dive, of our little baby seal's dive, how many minutes have elapsed? 6 minutes. And what's the depth? The depth is really negative 302.4, but you can get away with just putting in 302.4 here. All right, what's another point we know? Our baby seal lives through this thing, this ordeal. 12 minutes later, what's going on? Our little seal's back at the surface. And then we've got this other point, 10 minutes, so like, you know, this is 12 minutes, this is 6 minutes, so like right here, 10 minutes, and we want to know where our little seal is at. So we want to know why. Guys, there are a bunch of different ways to do this problem. I'm going to teach you the blue-collar way with just a quadratic equation. So it goes like this, y equals, and then you've been doing this for years, ax squared plus bx plus c. We've got a bunch of x's and y's. We need to know a, b, and c. C is really easy. It is the y-intercept. What is the y-intercept in our little story? Well, it's like where we started this whole process, right? 0, 0. So c is just 0. So that means c doesn't even matter. I'm going to need two things. I'm going to need a and b. I have x's and y's. I can use simultaneous equations to get there. So I'm going to use 2 points. This 0, 0 point's not going to help me very much. I'm looking for this one. I should have circled it. I can use these 2 points to get there. Starting with this one, y, so 302.4 equals, I do not know what a is, but I know that x is 6. 6 squared is 36. So 36a plus, I don't know what b is, but I do know that x is still 6. So 6b. All right, now I'm going to do my next point. Y is 0 equals, I still don't know what a is, but I know that x is 12. 12 squared is 144. So 144a. Still don't know what b is, but I know that x is 12. 12b. When I have two equations, my goal is to add them or subtract them to make something go away. Can't do that here. So I'm going to multiply or divide one of my equations. I'm going to multiply this one by 2 to get to 12b. So when I do that, I'm going to get 2 times 302.4. Obviously, calculator math. 604.8 equals 2 times 36 is 72a plus 12b. 6 times b. 6 times 2. 12b. All right, now I'm in business. That doesn't matter anymore, and I can subtract. So when I subtract, 0 minus 604.8, negative 604.8, 144 minus 72, 72a, and then 12b's go away. Anybody can do this, especially with a calculator. I'm going to do 604.8 divided by 72. Remember that I got a negative, and a is negative 8.4. Now, got to figure out what b is. In order to do that, I just want to use one of these points. I'm going to use this point right here because I got no zeros in it. So it's 302.4, that's y, equals ax squared. I know what a is. It's negative 8.4 times x squared. So times 6 squared times 36. Plus, I'm looking for b, so I know that it's 6b. Not that hard, got a calculator. 8.4 times 36, remember you're dealing with a negative, so it's magic. It's 302.4 equals negative 302.4 plus 6b. Okay, so the 6b is going to stay on the right. It's going to be 302.4, it's going to go across, so it's going to be plus 302.4. That's 604.8. Easy enough. Divide both sides by 6. And I'm going to get b equals 100.8. Okay, I got all the information I need. Now I just need to do this right here and solve for y. Y equals ax squared, so negative 8.4 times 10 squared, so times 100, plus b is 100.8 times x, which is 10. Negative 8.4 times 100 is negative 840. 100.8 times 10 is 1008. You're going to do this math on your calculator, and at last, after running out of room, you're going to get y equals 168. And that's the answer, 168. If you did negative 302.4 here, you would get negative 168, and then you'd say, wait a minute, depth can't be negative, that's not the way we talk, so we're not going to put in negative 168, we're just going to put in 168. Guys, this problem sucks. It's really hard. You can get it right, though, with a bunch of work, and move on. We're on SAT Practice Test 9, Math Section 2, Question 21. What's the level of difficulty? It's definitely stupid hard for pretty much everybody. Most people are going to find it crazy stupid hard. A lot of people aren't going to have any idea what to do with this problem. The area of a rectangular region is increasing at a rate of 250 square feet per hour. Which of the following is closest to this rate in square meters per minute? An EBAL testing service says use 1 meter is 3.28 feet. All right, let's just say you don't have any idea what to do. You're one of those people. If that's the case, is there a strategy? And there is. And the strategy is go against your hunches. Average person here is going to say increasing at a rate of 250 square feet per hour. Well, that seems like a lot. So how many square meters per minute? Seems like it should be a lot. And they're going to gravitate to these bigger numbers. So if you have no idea what to do, go against your hunches and pick one of the smaller numbers. As far as what to actually do, it's really just a simple proportion. What's the proportion? It's 250 square feet per 1 hour. 250 square feet per 1 hour. But that's not what we want. What do we want? We want square meters per 1 minute. All right, the minutes and hours part's pretty easy. How do you convert hours to minutes? You know this one. It's 250 square feet. How many minutes is that? It's 60 minutes. Okay, so you're halfway done. Let's draw a square meter. This is a square meter. 1 meter. How else can we look at this? We can also say that this is 3.28 feet. And what's this? It's also 3.28 feet. How can we figure out how many square feet it is? We just multiply those things together. And we get this decimal thing, but look what it says. It says, which of the following is closest to? That's a license to round. So I'm going to round to 10.76. You could even round it further if you wanted. 10.76 what? Square feet. So this is a square meter. It's also 10.76 square feet. Same thing. All right, you don't have to draw this, but think about it. We want to do 250 square feet. So how many of these things is going to fit into this thing? How do you find that out? You divide. 250 divided by 10.76. When you do that, you're going to get, again, you should round, 23.23 or so. So 10.76 square feet, you can do that 23.23 times to get to 250 square feet. So this is 23.23 what? Square meters. So 250 square feet is the same as 23.23 square meters. And how long will it take to do 23.23 square meters? 60 minutes. Same thing as 250 square feet. But we don't want 60 minutes. What do we want? We want 1 minute. And we want to find out how many square meters. We don't know. So it's x. So it's 23.23 over 60 equals x over 1. Fraction equals sign fraction. You're just going to cross multiply. 60x equals 23.23. How do you do that? You divide both sides by 60. And when you do that, I'm going to write it down over here, you're going to get some nasty go on forever decimal. What's that closest to in these answer choices? It's obviously A. That's the right answer. Get it right and move on. We're on SAT Practice Test 9, Math Section 2, Question 22. What's the level of difficulty here? Level of difficulty is this problem sucks. This whole Section 2, the last few questions have been really, really hard, and this one's just like the coup de grace, man. It's real difficult. Got these two equations. In the given pair of equations, A and B are constants. The graph of this pair of equations in the xy plane is a pair of perpendicular lines. Which of the following pairs of equations also represents a pair of perpendicular lines? So what are we looking for? We're looking for perpendicular lines. Before we get to that, let's say that you have no time here. Write A, B, C, D. Don't worry about the question. Look at these two equations. Look at the answer choices. If you were to say, like, what's the easiest looking answer choice, what do you think it is? And I would argue that it's D, because AX plus BY equals 1 is the simplest thing. It doesn't have a 2 in it, right? That makes all of these second equations more confusing. And then 5x minus 7y is a little bit simpler and easier than this other thing. Also, all of these answer choices, A, B, and C, have 10x plus 7y equals 1. One of those is probably going to be the right answer if three answer choices have the same thing. So for all those reasons, I'd get rid of D if I was going to guess. As far as actually how to do the problem, what's this problem about? This problem is about perpendicular slope. And in order to find perpendicular slope, you got to do two things. You got to flip the slope sign, and you got to flip the slope fraction. So what we're going to do is we're going to find the slope of this line, and then we're going to flip the sign and flip the fraction to see what the slope of this line has to be. So 5x plus 7y equals 1. And what's the slope? And we don't know, because slope, the form of the equation, has to be y equals mx plus b. 7y, that's on the correct side. 7y equals negative 5x plus 1. We're going to have to divide every term by 7 to get y naked and alone. So we're going to get y equals negative 5 over 7x plus 1/7. This part does not matter, so we're not going to worry about it. So the slope of this line up here is negative 5 over 7. If we flip the sign and flip the fraction, it's going to become positive, and we're going to flip it, so it's going to be 7 over 5. So, all right, so we're going to do that line. AX plus BY equals 1. Again, we got to get it in this form. So it's BY equals negative AX, and this plus 1 doesn't matter. All we're dealing with is slope. We're going to divide through by b to get y by itself. And we're going to end up with negative ABX, negative A over BX. All right, so negative A over B equals 7 over 5. I don't really like that. What's A over B? A over B is negative 7 over 5. All right, ETS tells us that A and B are constants. You cannot plug in for constants. But in this case, you essentially can, because the relationship of A to B is negative 7 to 5. So it has to be numbers that fit that relationship. It could be, for example, negative 14 and 10, negative 21 and 15. But what's the easiest thing? The easiest thing is to make what? A equal to negative 7 and B equal to 5. All right, so we're just going to go down to the answer choices. We're looking at answer choice A here. We've got 10x plus 7y equals 1. And again, we got to find the slope, so we got to get it into this form. So it's 7y equals negative 10x, plus 1 doesn't matter. Got to get y by itself. Y equals negative 10 over 7x. All right, so what's the slope? Slope is negative 10 over 7. So if we flip the sign and flip the fraction, we're looking for a slope of 7 over 10. I'm going to circle that. The second equation is AX minus 2BY equals 1. All right, so negative 2BY equals negative AX. 1 doesn't matter. I'm going to divide through by negative 2b. Remember that a negative divided by a negative is a positive, so it's, what's the slope? It's a over 2b x. Now what's a? A is -7, and B is 5. So it's 2 times B, 2 times 5, which is 10. -7/10. We were looking for 7/10. Is that the same? It's not. Sucks. Now, if you think about it, why we're so close, we got -7/10, we're looking for 7/10. What's the only difference in B? The top thing's exactly the same, so we're going to get the exact same thing. We're going to get it -10/7 as the slope, and we're looking for 7/10. The only difference here is that this sign is changed. That's going to change the sign of this fraction, which is going to make it 7/10. So if you're like push for time, you say, hey man, it's probably B. But let's go ahead and do it. We know, finally, we know something. We know that 10x plus 7y equals 1. We know the slope. What is it? For B, the slope is exactly the same. It's -10/7. And then run out of space, and I'm sorry, I'm looking at ax plus 2by equals 1. All right, so I got to get this in the right form. 2by equals -ax. Again, plus 1 doesn't matter. Divide through by 2b. So I'm going to divide through by 2b. All right, so what do I got? I got negative, I'm going to do it here, -a/2b x. Here's the slope. Now think about it. -a, -7 is 7/2b. 2 times 5 is 10. It's exactly what I was looking for. And I finally got to the answer. Congratulations, you got to the end of a very difficult Section 2 of SAT Practice Test 9.